What are we going to substitute in this case? Y, you reckon? Y, okay. Do we want to rearrange the first equation or the second equation? The first equation? Okay. If we rearrange the first equation, it'll look like this. Y is equal to 10 divided by x. Okay. You want to do the second one? You don't like that one, alright. If we rearrange the second equation, it would be 9 take away 2x. Okay? Now, this was the second equation, but I've adjusted it now, so let's call it 2a. Okay, it would be incorrect to call it 2 because that's equation 2. Alright, and we've got equation 1, which is here. Do I want to substitute equation 2a into equation 1? Or do I want to substitute equation 1 into 2a? 2a into 1. Okay, so if here's equation 1, then what it'll look like is x times y is equal to 10, but I'm not going to write y this time, I'm going to write 9 take away 2x. Okay. What do I do from here onwards? Expand bracket. So x times 9 is 9x. X times negative 2x is negative 2x squared is equal to 10. We have a quadratic function. What do I do? Bring the 10 over to this side. Okay, now that's fine. However, it would be better to move these two terms to that side. Tell me why. So that the coefficient of the x squared will go from negative turns to positive. Okay, and then we don't have to deal with negatives. So, 0 is equal to 2x squared, take away 9x, add 10.
You still have a negative coefficient.
No, I don't actually. Not for the x squared. My coefficient for x squared is now positive. Okay. Alright. Next, what do I do? What do we?
Factorize it.
Factorize it. Let's try and do that up here. Okay. Factors of 2 has to be 2 and 1. And now we're looking at factors of 10. What are the factors of 10? 1 and 10, 2 and 5. We need the pair that's going to make a 9. Don't forget that one of them is going to be doubled. 5 and 2, you reckon? Okay, so does this look right?
Yes, I'm wrong way.
You want to switch the 4 and put on this side? The 5 over here?
Yeah, that would be 2, and then you put on that side.
If I leave it where it is, 2 times 5 will make 10, and 4 times x will make 4. Together that makes 14. If I subtract them, I'm going to get 6. So neither of those makes the 9 that I want. So Ellen, I like your thinking. If we put the 4 there and the 5 here, 2 times 4 makes 8. 5 times 1 is 5. Add them together, we get 13.
So it's not
So it's not 4, it's 2.
2 and 5. 2.
It has to be 2 and 5, not 4.
5 on the left. Oh yeah, because factors of 10 is 5 times. No,
Thank you, that's not supposed to be 4, that's 2. Double the 2, I get 4. Thank you. 2 times 2 will make the 4. Add the 5, I get the 9. That's what we want. Excellent, so that's in the right place now. Okay, and if the 9 is negative, that means the larger of these two gets to negative. Which one's larger? 5 is larger than 2 times 2. And a negative times a something is a positive. Negative times negative. So we factor factorized it, what are the values of x?
Is it 2 and 5 over 2?
5 over 2
5 over 2 and
2 negative.
and 2. Excellent. So we haven't found the points of intersection just yet, but we've found the x components. Let's solve for the, using equation 1, let's solve the first y component. So x, y is equal to 10 when x is 512 times y we get 10, so y is equal to 10 divided by 512, which comes to how much? 4, that's right. So the point of intersection in this case is 512, 4. Righto, Steele, you get to do this one. Plug in the second value for x. What is it?
2.
2 times y is equal to 10, so that means y is equal to
5.
5. What's the point of intersection?
4 and 5.
2, 5. Okay, so who can tell me what type of a function this is? We haven't studied it in depth, but you might be able to recognize it. If I rearrange x, y equals 10 to make y the subject, we get y is equal to 10 on x, which is the same as 10 times 1 on x, and 1 on x is a hyperbolic function. Okay. Looks like that. And over here, we have the second equation. What type of a function is this one? It's linear. And if we rearrange this to make y the subject, we get y is equal to 9 take away 2x. Is the gradient positive or negative?
Negative.
Negative, so it's going downward. And what's the y-intercept? 9. Okay, so it starts up high and it goes downward. So what we have here is a downward slope that goes like this. How many times did our algebra tell us it crossed how many points of intersection are there supposed to be? 2. One's at 2, 5, and the other one was at 2.5 and 4. So 2, 5 would be this one here, and 2.5, 4 would be this one here. So that's what it means. Okay, we'll close that.